Welcome everyone. In today's comprehensive guide, I will be walking you through the process of creating your very own geometry-game using Scratch. This guide should take you less than an hour to make. Let us dive in and unleash your creativity. I am excited to share a detailed and constructive walkthrough on how to create your own level. If you find this guide helpful, please let me know in the comments, and I will be glad to provide additional insights in a follow-up. So, let us dive in and start crafting your geometry-game. Let us start by creating our sprite by designing the player icon. Aim for a size of at least 35 by 35 pixels for your character. You can easily check the pixel count on the left side of your costume editor. In addition, let us enhance the functionality of our sprite by adding a second costume that will serve as the hitbox. For this hitbox, a size of 20 by 20 pixels would work well. This approach will help ensure your sprite is effective in gameplay. Do not forget to name your costumes. This helps us understand their various purposes and ensures we use them effectively. Naming them will contribute to better organization and communication within our game. After completing your player icon, the next step is to design your backdrop sprite. I encourage you to keep the design simple at this stage, as we will enhance it with background patterns later in the video. For now, using a dark magenta color would be a great choice. Once you have completed your backdrop, we can dive into the process of designing our level. We will be creating 3 unique costumes for this sprite, each serving as a different frame. I will provide more details on this later, but for now, focus on crafting your platform. In each costume, feel free to incorporate various obstacles to make the gameplay more engaging. Do not forget to add a white outline to the top of your platform. This will help define the ground for your player. In this video, you will notice that I intentionally selected a different outline color for the spikes compared to the floor. This choice is important because we will be adding a code that causes our character to die upon touching that specific color. To ensure everything works as intended, please set the outline of your spike to yellow with a saturation level of 12. This will help create a clear distinction in the code. Let us work together to create our code, focusing on making the level move effectively. I encourage you to follow along with the video closely for the best results. To clarify our objectives, this script will have our sprite moving from right to left while generating a new costume each time it moves. This lays the foundation for what we will build next. Once we start coding our player, we will see the level come to life. After you have created your script, you may notice that the sprite does not move when you press the flag. This is perfectly okay, as it simply means we still have a bit more coding to do for the movement to work correctly. Let us focus on adding the necessary movement code to your player sprite to ensure the level functions as intended. If you need to, feel free to pause the video to follow along at your own pace. The level now responds to the flag press, which is great progress. If you notice any bugs in the level design, I encourage you to take the time to fix them for an even better experience. One common challenge that many of you may encounter is uneven white outlines. This issue is quite simple to resolve. Just add a long line beneath the platform for each sprite. Doing this should smooth out the outlines nicely. I will also provide a demonstration of this solution in the video to help you. Let us begin by coding our player. Our initial script will focus on allowing the character to interact properly with a platform. It is important that the player remains on the white outline and does not slip into the floor. I will provide a bit of guidance to help you through the process. First, let us create a variable specifically for our player sprite. This will allow you to use the variable exclusively for that sprite, which is what we want. Now, to begin our script, let us create a custom block. Name the block knockloop and check the box that allows it to run without screen refresh. Additionally, make sure to add an input and label it dy. We will now be prompted to define the purpose of our block. Please follow along with the code and pause if needed. Now that you have defined your block, let us build on that by creating a game over code. Our goal is to have the player automatically restart when they die, while also keeping track of their attempt count. If you would like a tutorial on converting any sound into Scratch, please let me know in the comments below. Also, make sure to subscribe so I can create more of these guys. It is now time to create a script for player movement. Let us incorporate the first part of this script. You want to create another custom block. Make sure to check the box to run without screen refresh and name it icon or player movement, whichever you prefer. Now we can advance to the second part of the script. This section will focus on enabling our character to smoothly slide throughout the level while also allowing for jumps in response to pressing the spacebar or tapping the screen. With these features, we can create a more dynamic and engaging gameplay experience. In this section of the script, we will implement a feature where our character will perish if it comes into contact with the outline color of the spikes. It is essential to choose the exact color that matches your spikes for optimal results. Additionally, I will incorporate a dark gray color for the mini spikes, which will be displayed at the end of the video. Let us pay careful attention to this step, as it plays a vital role in enhancing the gameplay experience. It seems we have run into a glitch. I figured out that this specific code was giving us issues. I mistakenly mismatched these two codes. If you are trying to find it, it is under the no-clip custom block script. We fixed the issue. Now, when you press the flag, you can play your game. However, we still have one more thing to do. When you press the flag, you will see your character spawn above the ground, which is a great opportunity to adjust its positioning. Take a look at the right side of the screen, where you can find your sprite's X and Y coordinates. To ensure your character is positioned correctly, simply copy your Y coordinate value into the appropriate block of your code. For instance, my sprite's Y coordinate is -63, so then now I will paste that value of -63 in my code. This process is quite simple and can help enhance your character's placement. The game looks great so far, but there is potential to make it even better. One enhancement we can add is a trail of particles that the character leaves behind as it moves, similar to the effect in the original game. This will give the character's movement more dynamism and visual appeal. To start, let us create a small 8x8 pixel square for the particle effect. This will serve as the building block for the trail. Once we have that, we can implement it so that the particles follow the character as it slides through the level, adding that classic touch. For the script, we will begin by making the particles follow the player, ensuring that they trail smoothly behind as the character moves. Once we have that in place, we can add the necessary effects to fine-tune the particle behavior and make it function correctly. The script will require two key variables to work effectively, one for the transparency of the particles and another for their size. As the character moves, the particles will clone themselves with varying transparency levels and sizes, creating a dynamic trail that enhances the overall visual effect. This approach will allow us to achieve the desired look and feel for the particle trail. Once you've completed the script for the trail particle, I recommend starting by hiding your variables from displaying on the screen to keep things clean. Next, to make the trail appear on screen, go back to your player sprite. From there, add a Create Clone block and select your trail sprite. Place this block into the icon movement code. This will ensure that the trail is created and follows your character as it moves, completing the effect and adding that extra visual detail. The next step is to create an effect when your character makes contact with a spike or a wall, similar to the explosion effect when the character dies in the game. To begin, let's start by creating a simple circle shape, which will serve as the base for the explosion effect. Once we have that, we can add additional effects to make the explosion look more dynamic and impactful when the character collides with an obstacle. Make sure to create a custom block called DefTick and check the box to run it without screen refresh. This will ensure that the block runs smoothly without any unnecessary visual updates. Next, define the block to create a repeat loop that generates 40 clones. These clones will correspond to the explosion effect, executing the code for the visual effect, such as particle movement and appearance, each time the character dies. This will help create a dynamic and smooth explosion effect when triggered. Once you've created your explosion, click on the DefTick block to see the final results in action. If you notice that some of your particles are rotated, don't worry. To fix this, click on the Directions button on the right side of your screen and select the third option to prevent the particles from rotating. This adjustment will make the explosion look much cleaner and more polished, closely resembling the original game's effect. Now your explosion should look more consistent and visually impactful. Our game is looking amazing, and in just half an hour we've already built the foundation. But we're not done yet. To make it even better, let's add some finishing touches. One great way to enhance the game's visual appeal is by adding patterns to the background. These will give the environment more depth and style, making the gameplay experience feel even more immersive. Make sure to drag the level sprite scripts into your pattern sprite, as both share the same code. This will ensure that the patterns are integrated seamlessly with a level, allowing for consistent behavior and a smooth visual experience across the game. By doing this, you can easily manage the pattern and level elements together. There isn't much coding involved for this step. All you need to do is remove the speed variable from V, change X, block and set the value to -2. This will control the movement of your pattern. Don't forget to set the sprite to the back layer, ensuring that it appears behind the main gameplay elements. This simple adjustment will help your background pattern move smoothly and blend nicely with the rest of the game. If you playtest your game and notice that the pattern stopped showing, simply repeat the same steps we took for the level by adding a long line below the pattern design to ensure it keeps moving continuously. If the patterns overlap with each other, you can adjust the positions of the different costumes to make sure they don't interfere with one another during gameplay. This will keep the background looking clean and seamless, while enhancing the overall experience. Keep in mind, if you want to extend your level, you can create additional costumes and add different obstacles to each one. As you can see, I have 4 different costumes on the left, and what will happen is that the game will loop through these obstacles. However, if you want to make your game feel more dynamic and engaging, I highly recommend adding even more costumes and variety. This will keep the gameplay fresh and add more excitement for players as they progress through the level. A useful trick for handling collisions is to add a line of the same light yellowish color onto your wall. Remember, in the code we set it up so that if the character makes contact with that yellowish color or dark grayish one, it triggers a game over. I decided to add this line myself to help prevent any potential bugs when pressing play, ensuring everything works smoothly. This extra step can provide better accuracy in detecting collisions and improve the overall gameplay experience. We've successfully finished creating our very own geometry dash game. Go ahead and press play to check out the results. The entire process took me less than an hour to recreate, and the great thing is that you can now design any level you want, including those from the original game. If you'd like, I could make a follow-up to this guide, where we could add a finish line, a main menu, or any other feature you'd like to see. Just let me know. Thank you for joining me in today's guide. I hope you found it helpful, and I'll see you in the next video.